Hello, good morning. Welcome to another talk show, Xa Talk Show. We're gonna code Wolfram Language Part 2, writing a customized function to convert Wolfram Language graphics to SVG. So this is Part 2, and 2 days ago we did Part 1. So we made some progress, and let's continue. Now, if you are watching this offline, play at 1.5 speed minimum. And if you are here, say hi, okay? So let's start Wolfram Language. Play at 1.5 speed, okay? Not Emacs. We already got Emacs. Let's launch Wolfram Language Mathematica. Okay, new notebook. And new notebook 3, shift enter to evaluate it and start the kernel. Okay, magnify. So there we are. And here is my Twitter, Wolfram Language, Firefox, Emacs, and this is a new instance of Emacs. So let's make it what? Wait, so shift lock is on. I have sticky keys, undo, okay. Sticky keys, turn it off, okay. So now, let's begin coding, okay. So this is Emacs I'm using, and I'm using, I'm using Xafly keys, the most efficient key binding system for Emacs. And here's a source code, Xafly keys, and go to the top. You can get the package on GitHub. This is the homepage, Xafly keys. There's a video intro, like tens of them in the past 5 years. Xafly keys, and the left, the pink window shows all my command calls and keystrokes as I type them. Okay, so the font is really large. Okay, that's good. So close that, show today's talk show. And Wolfram Language, if you don't already, search for Wolfram Language for programmers on my website, xali.info, http, no S. Then you have a complete tutorial from the ground up for programmers. So if you have 1 year of coding experience in Python, JavaScript, this is good for you. No nonsense, okay, deep dive into the most advanced programming language, and you can download it for free here. Make sure follow this link, okay, wolfram.com/developer. Then you can download it for free. It's like 4 GB or something, because the Wolfram language is a magnitude more powerful than all existing languages like Python, Haskell, Lisp, or whatever. Okay, so let's start to code. So let me show you, okay? And in Emacs, I can code Wolfram language in Emacs. That is because I'm using Xa Wolfram mode. You can download it on GitHub too, okay? Thanks for Wolfram Research for sponsorship. Okay, so let's begin coding. So practical SVG tutorial. You know, in order to do this, you need to know SVG, of course. So there's also practical SVG tutorial. And here is code to write a clock. So you can see the code is just 50 lines, 60 lines, JavaScript to create SVG. So you need to know this in order to do what we do today. Okay, if you are here, say hi, okay? If you are not here, play at 1.5 speed. Now, let's just begin code, okay? So start the Wolfram language. So let me start to show you graphics. Okay, so this is graphics. Anything of 2D graphics begin with this function, graphics. And last time we did a circle. So let me just demo Wolfram language graphics. Okay, circle, you need 2 arguments. The first one is the center. The second one is radius. Let's say 1. Okay. Okay, copy that and paste in Wolfram language, and you get a circle. Okay. Then Shift Enter. Okay, then you want to Control L to copy the previous input. Then let's add option axis, axis true. Okay, now this will draw axis, so you have a clear idea where the circle is. Okay, so that's one example. So let's copy that. Let's copy the code here. Now you cannot show graphics in Emacs. That's why we are running this in Wolfram Notebook. Okay, so copy that. So let's do that. So that's one example. This is the most simple example. This is an example with a option axis true. Then let's do another example. Let's see line. Okay, so now we're gonna include a line in here. So first of all, the first argument is gonna be a list of graphics primitives. So this part is gonna be a line. So this is the function for line. So for a line, you need 2 points. So let's say 0, 0 to 1. Okay, so that is what we're gonna plot. Okay, so go down here. So this is the fundamentals of Wolfram Language graphics programming. There you go. Fantastic and beautiful. So now, okay, so now that's the basics of Wolfram language graphics. So so this circle and line, those are called graphics primitives. You see, circle and line, that's graphics primitives. So you got quite a few. You got rectangle, you got others. So let me show you. Okay, so go to Wolfram Language for programmers. There is a section for graphics, expression, atom, and list, number, boolean, list, expression, atom, variables, conditional, loop, iteration, define a function, pattern matching. This is the most advanced critical pattern matching in Wolfram Language. And data structure. Hi, hello, sunrise midnight live. Hello, Kitastro. Data structure association, that's a dictionary or hash table, advanced symbol graphics there. So graphics, you don't have to, you don't have to like learn the complicated programming. You can simply plot. By default, there are hundreds like plotting functions, such as, for example, we can copy that. Let me just show you. So, so then you can rotate it and so on, like parametric plot 3D, or surface plot 3D, vector graphics, vector fields, pie charts, and so on. Okay, so that's simple, just plotting it just like the way you use a graphing calculator. But obviously you can program it, and that is where the power come from. So let me so we want to go to so here is the list of like how to use the default graphics. Then what we want is graphics programming. So this is like what we are doing today. So graphics programming, so first of all, you have what's called graphics primitives. Those are like basic shapes. So for example, if we go to the SVG tutorial, SVG basic shapes, you have line, which is represented by this, this XML element line. And here's a full example in HTML. If you copy that, create a file, show in browser, it will draw a line like that. So you got line, rectangle, you can have corner, round corner for rectangle. You can have circle, ellipse, polygon, and polyline, and text and path. So these are like the graphics primitives. Now in SVG, how do they call it? Do they call it graphics primitives? Maybe not. They just basic shapes. I'm not sure if they have a particular name, but anyway, in different programming graphics languages, you have different name. So in Wolfram language, it's these are called graphics primitives. Okay, so circle line, but what I want to show you is a lot more. So you got points, so you got point, line, polygon, text, disk, circle, rectangle, and much more. Okay, so you can look at the reference. So these are 2D. So far I listed them. Those are 2D, two-dimensional graphics primitives, but there are also three-dimensional ones. So, but for SVG, SVG is just for two-dimensional. So we're gonna focus on the two-dimensional ones, simple. So you can click on this link. That's the Wolfram Language reference website. So you can see the entire list of graphics primitives, which include, you know, like the ones we talked about, disk. Then you also have field curve, like getting complex. Okay, you got conic hole region, circumsphere. Circumsphere is like you can specify 3 points. Then 3 points, yeah, you'll draw a circle passing those 3 points. You also have circle, of course. You have B-spline curve. You have AAS triangle, that is angle side triangle. You give two angles and give one side length, it draws a triangle. You have like, and you also have ASA triangle. Okay, you have arrow if you want to draw arrow. So, you know, you have half line, which is like a ray. Like normally you have a line segment or several of them forming a path, but you can have a ray, like starting at one point into one direction, but it's infinite line, half line. Okay, so it's like a ray. Then you also got half plane. Wait, these are 2D or 3D, half plane. Wow, you got a half plane. So basically that's like a let me show you where half plane, infinite. So you got infinite line, which is a line past, you know, infinitely long on both sides. So let's see. So we got a half plane. Half plane is like a linear equation, linear inequality. So it feels like it fills the plane, half of them, by a line, like one side of it. You got half plane. You got inset. Actually, I'm not sure what is inset. I think that's embedding a image. Inset. I'm not sure what is inset. Represent an object inset in a graphics. Yeah, I think that's embedding a graphics into a graphics. So close that. So you got, you know, you got like 50 or over 100, about 50 graphics primitives. Okay, rectangle, raster, which is a bitmap image, polygon, point, parallelogram, locator is dynamic, more complicated, and text and triangle. Okay, so that's those are graphics primitives, and we are using two of them, circle and line. So now, so that's an example. Okay, so that's a basic fundamental example of graphics programming, two-dimensional graphics in Wolfram language. Okay, now we gonna, so last time we gonna, you know, we need to write a graphics to SVG. So let's go to 2 days ago. We did yeah, actually we did so many sessions. So let's go to, let's visit we did, wait, 709, 769, 789. So yeah, so we did three of them before, because this can get very complex. So far, actually, today is like the 5th. But previously, we don't actually have code. We went into something else. So anyway, so let's get back to, okay, so let's get back to code. Okay, so let's show today's talk show. Today's talk show. Then let's go to 2 days ago, episode 717, and let's grab the code because we already wrote the code. Okay, let's copy that and show today's talk show. Okay, so let's start a new Wolfram language code, paste it there, and pop it out. So here's the code. So this is the inline documentation for this function, graphicsToSVGString. Okay, so what we're gonna do today is we're gonna add. So this function yesterday, 2 days ago, we coded that already converts a circle, okay, to SVG. So we want to. So today we're gonna add converting to line. We're gonna modify the function so it does lines too. Okay, so 2 days ago we wrote this function that convert circle to SVG. Today we're gonna enhance the function so it does line too. Okay, and we're gonna make it actually export to a file. So right now it just output a string, but you actually need to save to a file. So this is going to show you how do you take a string and save it as a file. So first of all, let's do the line. Okay, so let me tell you guys how the code works. So the code is so you got this this is called rule delayed. It's a delayed set. Okay, colon equal. So on the left hand side is a pattern. So that means whenever Wolfram language see this syntax, this code, and it is a pattern, this underscore low line means match anything. So whenever you see something graphics to SVG, then inside it is graphics, then inside it is anything, and that will match. Okay, and whatever the matched expression is gonna be named GRA. That's a reference. Okay, so what we do once you match is you have this basically that is string join. Okay, so let me just show you. Let's say a string some and another string thing, we want to join them. So what you can write is that's a shortcut. That would be exactly equivalent to this. Okay, let me run it. String join something. Am I doing good? Okay, so you see something. Now let's run this code. It's gonna return exactly the same thing. Okay, that's just a syntactical shortcut. Okay, so now this function, when this pattern match, what it does, you see this bracket, that's a shortcut, right? So it's just one huge string join. You begin by this string SVG header, SVG width and height, and at the bottom you can also see the closing tag. Okay, now so you join, then you got this part. So the middle part is again a string join here. Then that at sign, it just means square bracket, another shortcut. Okay, so in the middle you string join this expression. Okay, so this means replace all of the graphics. Okay, this GRA thing, which is whatever is inside graphics, then you replace it by this rule. Okay, so what does this rule mean? This means given a pattern, so whenever inside the GRA, whenever you see circle something something, anything, like circle braces, then anything, name it X, and anything, name it Y, then another anything, name it R. So whenever you see this pattern in the GRA expression, you replace it by this. Okay, so what we're gonna replace? We're gonna replace string join, another string join. So you can see, string join, circle, then X to string, then circle CX is the X coordinate. That's SVG syntax. Okay, then that CY is the Y coordinate. Okay, to string Y. Then R is the radius in SVG syntax for circle, then to string R. Then you give it a style, fill none, stroke blue, stroke width. Okay, so that's how this function works. Basically, just a bunch of join string, mostly by this replace or the pattern matching. Find any pattern that is of this circle thing, replace them by this string. Okay, then wrap it with the SVG header, SVG tag. Okay, so we demonstrated that works. So for example, so copy all, so let's show it again. Okay, so paste it here, paste it. Okay, so remove this example, delete that. So delete 2 days ago. Okay, so we got clear, then inline documentation. Okay, then our function is here. Okay, our functions is here. You can see the GRA is green, syntax coloring. You see, those are patterns. You see this green, GRA, and this X and Y. Those are patterns. They highlighted, become green. Okay, then, okay, so now split this cell, Control-Shift-D to split it. Okay, so here is the definition of the function. Okay, now Shift Enter to evaluate it. Done. Now you see input 6 right there. So now we run the code. So we give it a graphics and 2 circles. You see, we don't want the documentation. 2 circles. Circle 0, 0, 1, 0, 2, 1. Then Shift Enter. So you got this string, SVG width, height, then a circle, okay, then another circle. So that's how it works. Okay, took like 20 minutes to explain what we did. So it's a node or tag or element. Naming is not consistent, right? Right. So that's about SVG. So circumsphere for a Voronoi diagram is where I first learned it. Okay, fantastic. I first learned circumsphere in geometry because back then, so circumsphere is very interesting with triangles, because when you have a triangle, you can circumscribe a circle around a triangle. So that is basically a circle passing the 3 points of the triangle. So that's a circumcircle. Okay, circumsphere is a 3-dimensional version. You can do that with the tetrahedron. Okay, so anyway, for the plane 2-dimensional, you got a triangle, any triangle. Then if you have a circle passing those 3 points, that's a circumcircle. Then you can have also what's called inner circle. What's it called? Inscribed circle, which is a circle, the maximum size, but inside the triangle. So the circle will touch the 3 sides of the triangle. Okay, very interesting. Then you got also lots of other, so lots of other so-called centers. Like when you have a circumscribed triangle. Okay, we getting into like interesting geometry. So for example, let me draw it, and you know, we are digressing, but 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 let me do that a little bit. That's fun. So we want let's see, snip and so now I can draw. So let's say if you have any triangle, then you want to draw a circle passing these 3 points. What would that be? Oh God. So that would be almost like that. Okay. Then you can also have a inscribed circle. Okay, so each of the circle will have a center. So that's a center A, and that's another center B. So these two centers are related to the triangle. Now, there are several other centers of a triangle. So for each side of the triangle, if you drop a perpendicular, like from the opposite point to a side, from the opposite point to a side, but perpendicular to the side, then you draw another one here. Okay, that's another circle. That's another center. Each one, they have a name, like ortho center and other in center and whatever. And there's more. Okay, there's quite a few more. So that's how I learned about this circumscribed circle, circumcircle, circumsphere, and so on. Very interesting geometry. Save already exists. Yes. Okay. So let's go on. Many plotting primitives. Wow, that's a lot of episodes. Is the Wolfram language patterns all the way down? Yes, Wolfram language is a pattern matching. Basically, pattern matching is the main way it does computation. Okay, it is like the main way to do computation. So in computer science, it's called term rewriting system, term rewrite. So what basically in practice what that means is that you define a bunch of rules whenever the programming language, the code match those patterns in one of the rule. So a rule has left-hand side and right-hand side. So the left-hand side is a pattern. So you have a bunch of like hundreds or thousands or million of rules. So whenever you evaluate any expression, like any expression you evaluate, the Wolfram engine tries to see which rule it match. So if it matches a pattern on the left-hand side of the rule, the right-hand side of the rule says how to replace it. And in fact, that's what we are doing here, this function. You see, this is the left-hand side, and this is the right-hand side. So that's a rule defined. So now when we run this code, the Wolfram language sees that, oh, this expression began with this graphics to SVG. Then inside it's a graphics match, and inside it's anything match. Then this rule kicks in. So it does whatever the right-hand side replacement do. So that's a result. Okay. So, and this is, in fact, this is like the main core way of doing computation in Wolfram language. That's how Wolfram language works. In other language, you got, you have object system, you got, object system, function system. You can't explain how they work, how they do computation exactly, because they compile to, like many of them, they compile to, like they do computation in terms of the CPU, like memory, bytes, and data types. Like data types, you have integers, you have floats, you have strings, you have objects, then you have methods that, so their computation model in Python, in JavaScript, in Golang, in Haskell, in C++, in Julia, in C, their computation is based on for C and C++, for example, their computation is based on bit diddling, in terms of the CPU's like low-level architecture, in terms of bytes, basically. Like everything is just become a byte, and what do you do with a byte, okay? But for higher level languages like Python, JavaScript, or Emacs Lisp, their computation is not bytes, it's higher level, but it's you should, like it's hard to, they don't specify it exactly, but in their language specification they kind of tell you what's their model. That's the word, model of computation. They kind of tell you objects, and so on, okay? So in the case of Lisp, it's based on basically a list. Basically everything is parenthesized list, okay? So for example, you can look at my Xafly keys code, source code. So that's Emacs Lisp. So if you, let's say, let me scroll up 4,000 lines of code. Let's go up to something useful. You see, so let's say, delete current file, make backup. Okay, so you see the Emacs Lisp code, and you see all the paren, they are actually a list. So the Lisp computation model is basically based on manipulating list. Okay, that's why actually it's in the name, LISP, which stand for list processor. Okay, that's the origin of Lisp. Okay, so computation model, that's kind of computer science. So every programming language have some kind of computational model. In the case of Wolfram language, it's mostly basically just text replacement, find and replace. Okay, that's it. You type whatever, that's a syntax, that's your code. You just do find replace. Okay, but in computer science, that is called term rewriting system. And this kind of model is the most powerful, suitable when you want to do algebraic symbolic manipulation. Okay, so that's why, other languages, they don't have that. They are less powerful, but, there's pros and cons, okay? So symbolic pattern matching and replacement called term rewriting system. Okay, so Wolfram language sort of like Jupyter Notebook. Yes, that's, Jupyter Notebook is copied Wolfram language. That's a history. The history of Jupyter Notebook, they copied Wolfram language notebook. Wolfram language, Wolfram research, they invented the notebook idea back in 1989. Okay, so that's about computational model. Hold on. So let's get back to this, but let me okay, so let's regroup a little bit so we have like coherent topic of what we talked about today. So we talked about triangle in center. So let me show you. Okay, so let me triangle in center. Okay, so that's one of the center of triangle. Wait, so search it, XOR lookup web, you can see right there, search it. In center of a triangle is a point where the three interior angle bisectors intersect. That's right, that's the one I didn't explain before. So there's another so let's go there. Let me just so here's a nice illustration. Triangle in center. Okay, now there's also other centers, so they are called centroid, they are called circumcenter, they are called orthocenter, and there is also Euler line, very interesting, and there's more actually. So so you just have to look up Wikipedia. So let me show you. So there's also barycenter. Okay, wait, no. So let me show you. Okay, so here is centroid. Here is circumcircle. We showed. Here is auto center. Okay, we showed that auto center. Yeah. And there's Euler line. This is very interesting. Okay, but let's not, let's go back to, so let's just copy it here. So because we talked about it. Okay, so copy. Yeah. Copy circumcenter, and what is this one? Centroid. Okay, delete, and this one is in center. Okay, each and every one is interesting. Okay, copy it. So close that, refresh. So we got a bunch of Wikipedia centers. Wait, something went wrong. Okay, so hold on a second. That's the, when you link, you just want the name, you don't want the full URL. Okay, so delete that. Undo, show in browser. So you can see those are nice Wikipedia links. You don't want the full URL, so remove that. So that's one thing we talked about. And meanwhile, we can show the pink window. Go back here, press. That command is called XAI move image file. So the image file is now here. And it also optimized the PNG. Close it, open it. So you see, so now show in browser. So we have we did that illustration. So, okay. And now we are talking about notebook history. So you go to XAI, you can actually just search xali.info, search notebook. So you got notebook file format, Wolfram Language get script path, notebook directory, Wolfram Language notebook tutorial, just basic history of notebook user interface. So open that. So there is also Closure. You can, Closure interactive notebook. Closure, that's like Jupyter began about 15 years ago, 2010 or later. So we go to the history of notebook. So here is Wolfram Language notebook, the history of notebook user interface. So you can see the first one, 1988, Mathematica version 1. Okay, and here is Stephen Wolfram talking about the history of notebook idea. Okay, then everybody just copied it, and the most popular copy is from Jupyter. Okay, so did they talk about this is Wikipedia. Jupyter has a page that credit it. Okay, so anyway, copy that. Let's put the link here. Notebook history. Okay, and close that, and notebook. So notebook, basic notebook, you can have headers like press Alt 1 title. Okay, so this should be title of this let's see. Let's have some coffee to refresh my brain. I'm out of coffee. Okay, one last sip. Mammograph. Did I use that correctly? I don't think so. I was thinking monograph. That's right. So this should be monograph. Okay, title, and then you have section. Wait, Alt 2 section. Then you can have Alt 3 subsection, something like that. Okay, so you can have bold, italic, whatever. It's like a markup. Okay, so that's about notebook. So okay, copy that. So let's just history of notebook and notebook intro. Okay, and okay, let's get back to what we're doing. How's going? Opto MTB. Oh, copy, the good thing. Okay. One thing I want to tell, let me digress one more. Okay, one thing I want to tell you is that the notebook is in fact the best interface. A lot of people, they like, they like the shell, so-called kind of idiotic, they call it repo. Wait, wait, not repo. What is the jargon they call this? For example, you can do ls. Well, I mean Windows, so I don't have ls, but I have you can, Emac this emulates the Unix ls command, so you can do ls, but you can start PowerShell. So you can, you type command, it prints output, then you type another command. That's the shell interface. That's shell interface or command line interface. And in Emacs, you can also have that. So for example, we are looking at eShell. Okay, so you can also start PowerShell. There it is. So that's PowerShell, and you can also start Emacs Interactive, IELM. Okay, so that's Emacs Lisp shell interface. Now, what they don't call it shell interface, they call it God, I must remember the word, but let me demo it first. Okay, so plus, let's say 23, then enter. There it is. So you can run Emacs Lisp, the programming language, like a shell, the shell interface. You type a command, it gives you output. Okay, so all these are shell interfaces. What is the word they use? So for example, I don't. Okay, so close this one, and go back to talk show. Open this directory in shell and control scroll to magnify. Then I can do I can do listing the okay, so you can, digressions. So what is the word for this interface? What's like a fad, idiotic name, which came from the scheme Lisp, but borrowed by the industrial coders like Python. For example, you can do that in Python too. Python, there you got it. So let's say 3 plus 2. This, what they call it? Okay, you guys remember repo? Yeah, right. That's right, repo. Okay, I said that before, I forgot. Repo, it's the most idiotic fuck by these people because the repo name, so let me show you a history, okay? Search for REPL. REPL, well, there, okay, jargon, repo, and hackers, okay. What is repo? Why is it called repo? What is the etymology of repo? Edict of the day. Any hacker using the term repo is to be despised upon immediately. Okay. So how should one call repo? It should be called command line user interface. Okay. Why should one call it command line user interface? Because first of all, you are an idiot. So etymology of repo. So why do they call it repo? Because it came from this book, Structure and Interpretation of Computer Programs. So repo stands for read, R, evaluate, E, P, print, P, L, loop, REPL, read, evaluate, print, loop. So whenever you do something in shell, that's kind of what's going on. You type something, you press enter, the program reads it, then the program evaluates it, then it prints it, the output, then loop, then you are back to the, prompt, okay? Read, eval, print, loop. Okay, so let's go back here and let's, this book. So let me just open that in a new tab. Okay, so read, eval, print, loop. This jargon came from this book, Structure and Interpretation of Computer Programs, a fantastic book. I recommend it. It's not a practical book though. Like you won't get a job if you read this book, but if you will get a job if you read Python books. Okay, so this is kind of the situation, because this is not exactly computer science neither. It's kind of like middle ground. Okay, this book I read it in 1998. Okay, so this book basically use that term. Then the Python idiots, they picked it up. So they think that, a shell bash, that's not cool. It's no longer cool to call a shell. We need something cryptic. That's when the Python idiots picked up the repo jargon. So they don't call it shell like Python shell. They don't say that, well, we got a repo. So, that's the situation. Anyway, back to my point. What I want to tell you guys is the repo interface, the command line interface is not good compared to notebook. Why? Because when you have a command line interface, you can only type one thing at a time, and you cannot refer to past input. Like, well, you can, you backspace and, you backspace, or in bash, you control R, like then that's the one you want, then you maybe modify it, But basically the idea is linear, input, output, linear, okay? Meanwhile, if you have a notebook interface, you can jump and modify each part anytime you want. For example, let's modify this to be center 0.5. So, then shift enter, evaluate. You see, you can copy any part, evaluate any part anytime. In this command line interface, you cannot. You are, forced into these linear sequences. Okay, so the notebook is much superior. That's the thing I want to say. And I have an article on that too. So let's regroup and let's put the link back so we organize on the things we talked about. Okay, so we talked about notebooks, then we got this repo jargon, origin of the repo jargon. So close that, and structure and interpretation of computer programs. Okay, computer, close it. And notebook, we talked about that. Okay, so what I want to tell you is this article, command line interface repo versus notebook interface, which is better? So I give you my thoughts, okay, my analysis, and we also demonstrated many command line interface in Emacs. Okay, copy that. So let's just paste it. Okay, and we also demonstrated Emacs. For example, we demonstrated Emacs IELM. So let's also get that link. So go to Emacs blog, open it, and search Emacs tutorial IELM. No, okay. So this interactive. Okay, so I don't have an independent page. So you go to Emacs List Basics, Quick Start, file name, extension, comment, print, output, working with Emacs List there. So evaluate Emacs List code. You go there, open it. So that tells you all the ways to evaluate Emacs List programming language. Then you can see this repo. Okay, so copy that. We demonstrated that. Where are we going? So okay, so today's talk show link list. Okay, so far, yeah. So that's a digression, and let's go back to our shell. So we open so many shells. So let's just copy. Okay, each shell, screenshot, close it. Wait, so okay, class talk show, close it. And what is this shell? This is PowerShell in Emacs. PowerShell, fantastic. Screenshot it, close it. There's a process running. Are you sure? Yes, kill it. And there it is, Emacs Lisp shell. Okay, IELM. We demonstrated. Close. Okay. Now is okay. So now we back to the talk show page. And lots of digressions. Let's put the images here. Okay, press. There it is, showing browser. Okay, we demonstrated several repo in Emacs. Powerful. Running concurrently. Okay, so now we back to Wolfram language. Yeah, so let's go. We wanted to do the line. Okay. Press help for the name. Yes. Repo terminal. Yes. Mammogram. Oh yeah, mammogram. That's something else. Mono. Okay, yes, I got it wrong. Monograph. Monograph means like basically an academic work, publication, monograph. So let's get to the code. So showing browser, we have the Wolfram code here at the bottom. So let's start to modify it. We already like wasted lots of time. Wait, so not that one. So this one we want to modify. So this string, let's copy it. Let's put it. Okay, that's just demo of the syntax shortcut. Okay, so now that's what we doing. Okay, so now code. No, so let's add. So now this code is hard to read. Actually, it is true. Wolfram language is kind of hard to read, even though technically it's like Lisp, it's fully nested, but when the code get complex, it's harder to read. Okay, you can see in Notebook they render it with automatic indentation. So for example, I demonstrated this many times. So you see, notice how the line got cut. So okay, so look at this circle. Okay, circle is a pattern. Now if I change the window size, you can see they automatically format in a nice way. You know, when they cut the line, those are points where the expression stops, like, you know. So this is fantastic feature, automatic formatting on the fly as you type. Okay, but the Python idiots, the Guido van Rossum, they thought, oh, we should have indentation baked into the syntax. So this automatic format started in 1996. Okay, Wolfram Language Mathematica version 3. I was there at Wolfram Language, Wolfram Research. Okay, this feature began in 96 or 97. Okay. And also I can format, you know, math formulas, but let's not do that today. Okay, so anyway, so let you know, we got far. Let's get back to get this to work. So So this part, so let's see, this part is for replacing. Okay, so this part is for replace all. You see that, and this is a list of rules. So let's cut that and make a list of rules. Okay, so paste, that's one of them. Okay, then we put another one, copy, comma, a new rule. So this rule says line. So whenever you see a line of this pattern, okay, so let's just name them A, B, okay, A, B, C, D, okay, 2 points of a line. You want to replace it by, now we need to look up the syntax for line in SVG, basic shapes. So syntax for line is that. So let's just copy it here. So paste it just for, okay, so basically that. Okay, so what we need to do is, so you got x1, y1, x2, y2. That's a syntax for line. So you say line x1, okay, then this is A, then x2, B, oh, this is y1, okay, so y1, this is getting tedious. So, oh God, x1, y1. So then you need x2, C, okay. Then you need x2, y2, D. Then style, what should style? Just stroke black, okay, stroke black. Fill, you don't need, just stroke black, okay. Line width, well, do you need stroke width? And let's leave it, okay. So I believe that's it. Let's put this back here, okay. So this is the SVG syntax for line, but in Wolfram language, the syntax is this, by this pattern. So whenever you see that, replace it delayed by this string. Okay, I believe that's kind of, I think that works. It's kind of compact our code. Let's hope that works. Let's hope. Okay, so let's try it. So that, and here we need to add a line. So now you got 2 circles. Okay, then you need to add a line. Okay, do we have an example line? Yes. Copy. Just paste it there. Okay, we got a line. So copy all. Paste it. Big code. Okay. Shift enter. Let's see. This is the output. Now, is it correct? So we can modify it. Shift Control L to copy the output. That's right. The whole thing is a string. Then, so you enter, you got the first circle, style, something. Then you got the second circle. something something. Then you got, there it is, a line, xy, x1, y1, x2, y2, fantastic, and style, fantastic, and then SVG. So looks like it's correct. Now, two primitives done. You got like 20 more, actually something like 10 more. Okay, so this function we made a progress. Now, next thing we want to do is let's make it, so let's put it back first, show in browser. So today's talk show, is it organized? Yes. Here's the code. Okay, so next thing, given a string, you want to write that string to file. How do you do that? I don't remember. So that's the next thing we want to do. We want to export this string into a file. So name it something SVG, that then we can show the SVG in a browser or whatever. Okay, for example, this output. So how do you write to a file? I don't remember. So let's go to Wolfram Language for programmers. Print no, number, boolean, list, expression, function, loop, conditional, pattern matching, data structure, advanced, symbol, principles, full form, graphics, read, write file. We want write file, so that is the syntax. WriteString, file name or path, then string. Fantastic. Just that. Copy. Okay, so let's demo. So first of all, demo this. Okay, so another one, Wolfram Language, paste it, pop it out. So let's see this test something. Okay, so file name here, then a string. Then you have to close it. WriteString. Why do you have to close it? WriteString to file. If the file no exists, it is created. If the file already exists, it is overwritten. Okay, so you gotta be careful. When done writing, close to close the file. Oh God. Okay, let's try this. Let's evaluate the code. Should be done. Then by default, if you give a relative path, it's saved in documents. Okay, documents on Windows. So let's now search for XX. Search XX test. No, it's not there. Where did you save it? Oh God. So that's when you need to read the documentation. But I didn't document it myself. Why is that? So let's see. Go to the directory, search XX test. Okay, it's saved in the current directory, whatever the directory you are in. Okay, so there it is. That's a file. That's a file. The current directory, I mean a temp directory. Okay, so close that. So that's how you save a file. Okay, let's close that, close that, close that. Write string to file. Okay, so now put it back, syntax correct. So now we want to change the function to write to a file. Okay, so let's that should be here. Okay, okay, now let's see. Here is our function. In fact, we need to define a new function, so let's do that. Okay, so copy, 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 and this part is testing. Okay, so a new function, paste there. Instead to string to file. Okay, change to string to SVG file. Okay, something like that. Change. Okay, now So documentation, export xgraphics to SVG as a file. Wait, now you need a file path. So the documentation is a graphics, then you need a file path. Okay, so export xgraphics to SVG and save it at file path. Let's name it X file path so that stand out, so that it doesn't have normal English meaning. You know, it might be confusing because now this is a parameter name, but the name embeds a meaning. So the parameter name also tell you it should be a file path. So that's what I do. Instead of just saying, for example, instead of naming it file path, because then when you document it, file path, the word file path has a meaning. You know, it means file path, but it also means the parameter. You know, so it might be confusing. That is why I always name my parameter names something not normal English. So you add X in front, something like that. Okay, so that is why. So export xgraphics to SVG and SVG string and save it at file path. Okay, so yeah, so that's the documentation, and now we just need to change these. Okay, we define that. So let me hold on a second. Let me wait. So now this function, what will it do is we don't need all these parts anymore. We want to just write to file. Okay, so copy that, write to file. So here it's going to be graphics GI and wait. So this actually we can just name expression. Okay, expression and file path. Okay, so this pattern match two things. So whenever Wolfram Language saw a code that began with xgraphics to SVG file, and inside it got two things, any two things, because that's underscore, that low line means a pattern of blank, means match anything. So whenever you see something, this SVG file contains two things, then what you do is you call you write file. So this part is the X file path. Okay, then the expression is toString, and there, you see, then you close it. So now you got two expressions. You want to combine them into one expression. So what you can do is well, normally you put a semicolon. Oh god, this is complicated. So one way to do it is you just put a paren. So this in Lisp, this is like PROGN, program group. Okay, you know, do you guys understand what I'm saying? Can't you just write to file the string? Yes. Okay, save from having to close every time. Oh, you can use save? I didn't know that. Do we have like save, tech save, URL save, dump save, HTML save? Oh god, cloud save, notebook save. Okay, let's see what is save. Hi, just joined. Hi. Save file name symbol. Appends definition associated. Append definition associated with all symbols. No, I don't think that's the one. Anyway, let's just go through the way I know. Okay. Anyway, that'll do it. Okay. So this function that should work. Oh yeah, close. This needs to be that. Okay. In fact, this function can be written is as like this. Okay, let me show you. Compound expression. Okay, compound expression. Then two things. The first thing is that. Then the second expression is that. Okay, then we don't need the paren. So you see, this is identical to this. Now you see that semicolon, that is just a shortcut. This semicolon is a shortcut for this compound expression. And this compound expression, if you code Emacs Lisp or Lisp, that means in Emacs Lisp, it just means PROGN, like grouping expressions together as one. Okay. Okay. Anyway, let me write it this way. So this way is kind of shorter. Okay. So I think that should work. Now we can try it. Yeah. So here's the test code. So graphics, and second argument is my fantastic function dot svg. Okay, we call in the function. So I think that's it. So in fact, we can run this without notebook. We can run this directly in Emacs because we don't need to show graphics. Yeah, actually we can run this. Yeah, so let's do it. So let's say evaluate the buffer. Let's see. Oh, fantastic. Process finished. This one. Open the file. There it is. So go to the directory. So that's a file. That's SVG. Open it in Inkscape SVG editor. So you have to wait Inkscape to open. So we got it. It is correct. It's saved to a file, but there's something incorrect. I know why. I'll show you. Okay, so you see, we got our circle there. We got two circles. You see how to see? Let's see. Can you see? You see, we got two circles and we got a line. Wait, how do you? Anyway, you see, we got two circles. We got a line, but it's off. So this is about SVG coordinates. So you see, in mathematics, coordinates is the y-axis. The more higher it is, the higher value it is. The positive side is up. The negative side is down. But in SVG computer graphics, it's the opposite. So the vertical axis, if you go down, the value is higher. If you go up, the value is negative. So it's reversed. So you got the coordinate issue. So also you got centering issue, because in mathematics, circle, you can plot a circle and usually it shows, 0, 0 is the origin in the middle. But in computer graphics, whatever you do, the 0, 0 is on the upper left corner. Okay. So you can see our code here, the width and height also needs to change, because right now we are plotting, a circle of 1 radius or 2, but the canvas is 100 by 100, so our circle become a tiny dot in a corner. So we need to, but at least it's kind of working. Okay, so what we need to do, let's close that, close that, close that. Okay, what we need to do is in this code here, you see this width and height, we need to change it. It needs to be the boundary of whatever is your current graphics. Like we are doing 2D, so the boundary, it needs to be whatever the minimum and maximum of x, and also the minimum and maximum of y of the entire whatever graphics you have. We need to find those values. Then we can specify here what is the width and height. Okay, so that's one thing to do. The other thing is you need to reorient the center. You need to flip the axis. So whenever y occurs, you need to make it negative. Then you need to move the whole 0, 0. You need to do a translation. Okay. And another thing you need to do is, what if you have, like, typically when you draw something, the x and y may be 1 billion, right? You can plot something, 1 to 1 billion. Like in real life, real world graphics, typically that's the case. So you need to kind of scale the whole coordinate. In other words, you need to have a user-defined coordinate, not pixels. Okay, by default, they are pixels. But your computer screen is only like, 3,000 by, 2,000 something, or even 10,000 by 5,000. But in real life, the coordinate may be a million. So you need to scale the coordinates. Okay, so that would be the next job. Okay, so you can look at, you can learn about SVG tutorial, and circle specifying styles, shape styles, viewport. That's what we need to do. Viewport, that explains the viewport in terms of pixels. Then you need to read about the view box, which is user coordinate. Basically, rescale the screen. Okay, like viewport is like the part of your screen, viewport. Okay, but you need your own coordinate of the canvas scale. So that's the next to do. Okay, so let's make a comment here. Need to center the origin. Okay, origin means the 0, 0. Need to reverse the y-axis, or any point, any coordinate, the y-axis needs to be reversed. And need to rescale the coordinate. That is SVG, so-called. In SVG, they call it view box. You need to create a view box. Okay, so put the code back, syntax correct, show in browser, and that's it for today. This let's make a screenshot. This SVG thing we created. Okay, Inkscape I haven't used for a long time. How do you space? Oh yeah, so you need to do that. And where is the scale here? Right. Scale it, and God, you need to. So Inkscape. Wait, let's. So right now we are 500 times larger. So we are like, I just want to make a screenshot of this so people know, can clearly understand what's going on with our example. So let's paste it here. Let's go to move the image here and look at it. That's correct. Now showing browser. Fantastic and beautiful. Okay, that's it for today. I hope you guys like it. We got a lot to do here. Anyway, it's fun. Are you using an XML helper or just directly writing the string? What do you mean? I'm directly writing a string. I'm not using any helper. What do you mean helper? In Emacs or what? I will use full English. Okay. Bye, guys. Okay, if you like my stuff, okay, go to xali.info, Xa Talk Show, Xa Code, which is xali.info, HTTP no S, and pay me $1,000. Okay, some people have done that for me. A few people in my life, they actually paid me 1,000. A handful. So if you like my stuff, go down, Patreon me, PayPal me, Amazon gift card me, okay? Thank you very much. You guys are the sponsor. Bye, guys. So let's shut down. We shut down in 2 minutes. So close that. Wolfram Language, fantastic. Close that. View box, copy the link. And back to here, we need to paste the link so people can see user coordinate, okay? And go back here, and we got viewport, SVG viewport. Also paste there, linkify, make a list, combine the two lists, okay? And remove the, okay? Close that. Wolfram write file, okay? Copy that and paste. Okay, so close that. Basic shapes, yes. Repo, we got that. Bye. 10 people, wow. So many, quite a few. I mean, 10 for me. So bye, guys. Happy holidays. Happy Christmas. Merry Christmas.